Hello everyone, I'm Thomas and this is day 7 of 100 Days of Code in IoT Challenge. Today, just gonna continue on the subject of improving the pressure coffee maker with the relay. So I'm just gonna start from where I finished yesterday. So that's gonna be connecting external power supply to the circuit we got built. However, before we switch to the building view, let me just quickly show you this warning message because I'm still going to be dealing with the high voltage. Okay, USB is disconnected. Let me just connect the buzzer first, as I promised. So for the buzzer here, what we are interested in, I'm not sure if I'll be able to show you this. Is it? Yeah, it is visible on camera. You see there is this plus sign in here. So this is where the plus needs to be connected. Also, on the other end, we have this wire here. And the one for plus is longer. It's like with the diode. So I'm just gonna pick some place here maybe. And I'm going to connect it. Okay. Like that or like that. Okay. So connected here. And now what I'm gonna do is to locate D2 pin, which is here. Let me just move this one a little bit so you can see. So we have D2. Right? I'm gonna connect it to D2. And then because this is a positive, this is a plus, that's gonna go here. Okay. And now I need another wire to connect the other side to the ground. That's gonna be easier because we have a common ground here. Right. Okay. So again, that was D2. You see the blue wire going to the plus of the buzzer, and then we have yellow wire going to minus rail here. Right. The last thing is this yellow wire, which is 3V3 pin on the microcontroller, and that is basically the power supply. I disconnected it before I connected this to USB. We're not using a USB anymore, so we're gonna draw the power from this rail. 3.3, it is here, right? Okay, so yeah, let me just move this a little bit so I can show you everything we have so far. Actually, this is pretty much it. Apart from the small change in the code that I'm gonna have to do for the time of waiting, this is pretty much it. So yeah, we got the relay here. I don't think I need to show. It's not really easy to. Yeah, let me just zoom out a little bit so you can see everything. Right. So now let's do the test. Just quick summary. So we have our pin D1, which is the gray wire, and this is connected to relay. It is controlling whether the relay is switched on or off. The yellow and orange wires connected to relay, they basically also connected to 5 volts power supply. Then we have, on the other side of the relay, we have the green wire. This is the plus from the battery. And we have the blue wire, which is, coming out from this side of the relay, and that is connected to the plus of the diode. And then from the minus of the diode, we have the black wire here, and that goes to the battery, right? So this is our separate, meant to be high voltage circuit. It is not high voltage at this moment because that's going to be basically replaced with the cable that I showed you at the beginning, where the coffee maker cable is going to be connected to. And another thing is, because we have those two connected to those two, right, the initial state of the relay, which means when the relay is switched off, the initial state is basically cutting off this circuit that is going to the diode, right? So initially the diode is off, right? If I connected one of those, it would have to be the blue one here, right? Initially that diode would be on, right? So that's how relay works. Okay, another thing, this D5 pin, the white wire, is going to the button on the one end, and the green one to the ground on the other end, right? It uses pull-up built-in resistor. So initial state of this is high voltage. When it's pressed, then it's going to be low voltage, but we already have this taken into account in our sketch. And those two wires here, the red one is connected to the ground of the power supply from the ground of the microcontroller, and the yellow one is, the plus from the power supply. Okay, so that's it. And I'm going to connect our AC adapter here, right? It's all ready, and now I'm going to switch this on. Okay, switched on, and yeah, imagine this green diode is the coffee maker, right? Everything's off now. I'm gonna press the button. It is on, right? For now it's 10 seconds. So we have 10 seconds. And that was 5 seconds of the buzzer, right? Okay, this is working. I'm really happy, actually, it is. So the very last thing from the code perspective is going to be change the value for 10 minutes. And I'm going to have to change this connection here, because we're not gonna need this diode circuit anymore and those batteries, because this is where the cable that we're gonna use with the coffee maker is going to be connected to. I'm gonna show you this in a second, but before I do that, let's try to use a different power supply, the one that I showed you at the beginning. So yeah, I'm just gonna remove the power supply module. Okay, and we're gonna use let me just show you again. So this USB module. So what we're gonna do is to draw 5 volts from here. And I would really like to have just a single source of power. So it's gonna be that USB. And obviously we have to drop down the voltage to 3.3. So we're gonna use the AMS 1117. Right. Okay. So as a first step, what I need to do is to locate 5 volts pin and the wire connected to it, which is a blue one, and the ground, which is here, and the wire connected is dark purple. Right. So on the other end of those wires, I have a white wire connected to it, to the blue one. So that's our plus. And the dark one, black one to the dark purple. So that's our minus, right? So what we're gonna try to do is to replicate the power supply lines as they were used with the standard power supply module. So what I'm gonna do is to connect the plus to the plus here, and the minus to the minus here, right? So yeah, at the moment, once we connect the USB to something, I'm actually gonna use the power bank, this one here. So when I connect it to power bank, here we should have 5 volts. Okay, however, we still need 3.3 on this side. In order to do that, I'm gonna use this voltage regulator, and what I need to do for that is to locate the VIN, which is the input. It is here, right? So here we have plus, here we have minus, which is ground actually. So what I'm gonna do is to use those wires and connect them like that. So the yellow wire is gonna be the plus, and the green one is gonna be minus. And I have to connect it to the 5 voltage power supply lines, right? So the yellow one is plus. Let's just connect it here. And the green one is minus, ground. So I connected it to the ground here. Okay. And now on the other side, this is the output, so this is where the 3.3 is gonna come from. So again, we need to connect the wire here. So that's our plus, the red one, and the orange one, that's the ground. And I'm connecting it to the ground here, right? So with this configuration, we essentially are gonna get the same voltages on the power supply lines as we had with the standard power supply module. Okay, so now let's test it out. So I'm gonna connect this USB to the power bank. Okay, connect it here. Just gonna put it aside because what we really wanna do is to just test this circuit. Press the button here, right? So everything is on. You can actually see on the voltage regulator there is a LED diode, the red one here. Okay, so that indicates we have power on those power lines, and also basically power drawn from the power bank. Okay, let me just test it out. So I'm gonna press the button. 10 seconds. Cool. Okay. Yeah. Few more seconds. Nice. Okay, so this is working. As you can see, this was the different option. This one is a bit cheaper option as well. A little bit more wires on the board though. However, yeah. I'm just gonna disconnect everything now and move back to the previous circuit with the standard power supply. But yeah, essentially, if you want to keep this one and you just want to work with this sort of design with the power supply being the just the USB module, you can go for it. Okay, I connected back the standard power supply. So now I'm going to connect this cable here to the relay. Before I do that though, let me just disconnect this diode and the batteries. So we don't need this anymore. Okay. And now essentially I'm gonna speed it up. But yeah, the plan is basically to replace this blue and red wire with those two blue ones, okay? So that's what I'm doing now. Okay, it is really important for those two cables here to not be to not touch each other, right? We don't really want to happen for this to happen, so I had to make sure it is connected correctly, right? And another thing is, once the relay is on, actually once this is connected to the power socket and the other end to the coffee maker, we're not gonna touch this, right? It's better to not touch it. We don't want to be electrocuted. Okay. So I'm gonna move this here. And yeah, let's quickly move to the code and change those values. So yeah, and then deploy. For the deployment, I've just realized I'm gonna have to, for now, just pull it up, yeah, and connect it back once the sketch is deployed. Okay, so now to the final stage. Right, so here is the code. We want to replace, first of all, we want this to not be at 10 seconds, but 10 minutes. So what I'm gonna do is to just put a 60 as a number of seconds. So we have 10 minutes, 60 seconds, 1000 milliseconds, and that is going to be moved to the constant. Let's just define a constant. We're going to call it coffee making time, and I'm gonna define it here. Coffee making time. Yeah, so that's the value for the coffee, and we can do the same actually with the buzzer. So it's not actually really beeping; it's just a pitchy sound. But yeah, let's say it's sound time, sound notification time, and that is actually 5 seconds. So that's just gonna be 5 times 1000. Okay, this is it. Let's try if it compiles. Yeah, it does compile. And let's deploy it. Okay, it's done. Now just quickly reconnect buzzer back. Yeah, since it was in the way of our USB cable for the deployment. Right. Okay. Connecting adapter back here. For now, everything switched off. And let's connect the coffee maker. So here's the coffee machine. First let me set it up. Okay, here I have a fresh coffee. Put this back. Okay, so this is ready. I'm gonna put it on top of that. Right, so for now we have this switched off. I will just put this back to the kitchen. Okay, so let me move this back here. Right. Okay, so here is our relay. This is not connected to the socket yet. Here we have, let me show you. So this is the coffee maker connected to our cable. Right, it's connected to the relay. It's all ready. This one is switched off for now. Okay, so now I'm going to connect this to the socket first. Okay, this is connected. Let's see if the electricity is not flowing. So I'm going to switch this on. Yeah, it's not on. The light is not on here. But we're gonna keep it like that. Right, okay, and now I'm gonna press the button here. And let's start the process of making the coffee. Ah, it didn't start. Why? Because I forgot to switch this on. Okay, so I'm gonna switch this on. Right, now we have electricity flowing in ESP8266. And again, 3, 2, 1, go. Let's start it. Okay, now it should take 10 minutes. And after 10 minutes, we should see the sound. This should be off and the coffee ready. Okay, that was successful. The coffee is ready. Okay, let me just disconnect it and get rid of all the electronic parts from this table. And I'm going to try the coffee. Okay, this is it for today. Thank you very much for watching. Tomorrow, the plan is to finally start doing IoT. So I'm gonna add some connectivity to the project. I'm actually thinking about the notification side to replace buzzer with something else. But yeah, that's gonna be tomorrow. And if you are interested in this type of content, you want to follow me doing my challenge, or you just don't want to miss the next video, subscribe to my channel. If you spotted a mistake, you want to ask a question or just give me a feedback, leave a comment. That's it. Thanks. Bye.